How to model dynamically HV or LV motor. In this video we will see how to create dynamic model. There are three options you can adopt to create a dynamic model of high voltage or low voltage motor. One is CKT model, which is circuit model. Another one is characteristic model, and here is alternate option, which is parameter estimation and tuning. With the help of these three options, we can create motor dynamic model. This video will cover this parameter estimation and tuning. With the help of this parameter estimation and tuning, how to create motor dynamic model, we will learn in this video. First of all, let's remove this one. Let's go to this motor. This is motor nameplate data, 850 kilowatt motor, 6.6 kV, and these are the full load, power factor and efficiency, 4-pole machine, and these are the locked rotor data. LRC locked rotor 650%, that means starting current. Here starting power factor, which is 15.03 X/R ratio, and here locked rotor torque, maximum torque and rated torque. Now let's go to this model tab. Here let's remove first. Okay, now with the help of this parameter estimation and tuning, we will create the dynamic model. For this, no need to select any other option, that is circuit model or characteristic model. Only we need to select this parameter estimation and tuning. Here parameter estimation and tuning based on nameplate data only. Whatever data you have put in the nameplate tab over here, based on that ETAP will calculate the parameters. What are the parameters? Let's say stator resistance, stator reactance, RS, XS, magnetizing circuit parameters, that is XM, RC, and locked rotor condition, that means the rotor parameters. So these are the electrical parameters we need to estimate to create the dynamic model of the motor. So with the help of this parameter estimation, we will create, let's say, input data. You can use only the nameplate data. When you are clicking here in the nameplate, you can see these are grade, that means the locked rotor data, that means starting current, starting power factor, starting torque. These cannot be changed or cannot be defined here. Maximum torque Tmax also, and full load torques like slip, full load current, full load torque, power factor, efficiency. All this data you cannot edit here, but if you click here user defined, then you can change, you can edit this locked rotor data, Tmax and full load data, except rated current and rated torque. these two we cannot change. Anyone you can select. Here I will select nameplate data because I am not going to change anything apart from the nameplate data. Now this is by default 0.01. If we click here estimate, that means we are instructing ETAP to estimate these parameters: stator resistance reactance value, rotor resistance reactance value, magnetizing circuit resistance reactance value. Let's see what happens. Click estimate. One error is showing machine parameters cannot be estimated. This is probably because of this precision. It cannot decide the precision level. That's why if you set 0.9 or other values, probably it will show yes. Now you can see these are the parameters. Those are estimated by ETAP software based on the nameplate data like locked rotor data, maximum torque and full load data. Based on this, ETAP has calculated these parameters. Now what we need to do, we need to update these parameters so that it can create the curve. Update. Here you can see these resistance and reactance values are reflected here. However, here are the nameplate data. There is the slight difference in between these. So these are the existing data, existing nameplate data, and these are the recommended based on the parameter generated. So if you update this, then your nameplate data will be changed slightly, will be updated based on this, which will be close proximity. I don't want to update this nameplate data or loading data or short circuit data, that means locked rotor data and characteristic data. So I will uncheck all the boxes here so that only the resistance reactance values of stator, rotor and magnetizing circuit will be updated. So click here update. As you can see here, the model has been generated, all the resistance and reactance value, and this is magnetizing circuit, XM and RC also. Those have been calculated by ETAP software using the nameplate data. And in the right hand side you can see this is the curve which has been generated based on the data, and also characteristic model ETAP has created based on, you can see this slip. This is the starting condition, slip is 100% and power factor was 15.07, and this is the current corresponding torque. So based on this ETAP has modeled. So this is one of the 3 options how we can create motor dynamic model. So in this video, up to this I will show you in another video this CKT model and characteristic model, how to create motor dynamic model.